Hi guys, today we're going to finish the one sample t-test from you, and congratulations you guys, this is your last day of new learning for the school year. I'm so proud of you guys. I'll have like a little recap video or I always do a little Opal's top 10 right before the last day of school. So I'll have one more video for you guys to watch, but this is my last video, okay? For new learning for the 2019-2020 school year. You guys, congratulations. It's been a wild ride, but I'm proud of all of you. And just keep smiling, you guys, okay? Keep smiling. So we have a one sample t-test from you today. We're going to finish that state plan do conclude. And I want to get to the conclude first, just because the p-value is a little more uncomfortable than it was before. So we have a one sample t statistic, the one sample t statistic of n equals 25 observations. For the one-sided test, the null hypothesis is mu is equal to 64 versus mu is less than 64. Has the value of t equals negative 1.81. Find your p-value for the test using your table. Okay, so this was the last step, you guys, of the do step from the video before. Let's just quickly go through it again. We need to know one thing. We know our t. Our degrees of freedom, okay, don't forget, are always one less than the sample size. So that's 24. So now I'm going to go to my table. Okay, oops, give me a second. I'm going to go to 24 degrees of freedom. And I've already forgotten, you guys, what that was, negative 1.81. So I go to 24. I scroll over to negative 1.81. Now keep in mind there's no negative. So whenever it's negative, what do you need to do? You take the absolute value. So the absolute value of negative 1.81 is 1.81. So our degrees of freedom right here, 24, okay? 1.81 is right in between 1.711 and 2.064, okay? Now I'm going to scroll up, which means my p-value is in between 0.025 and 0.05. So let's write that down now. Our p-value, 0.025 is less than our p-value, which is less than 0.05, okay? So I don't know what my p-value is. Sorry, guys, my couch is a little off here. I don't know what my p-value is, but I know it's somewhere between these values. Okay, so now it says, what would you conclude at the 5% significance level? That means our alpha is equal to 0.05. Now, a friendly reminder from when we did the z-test, I'll make a new little chart for you. How do I know how to conclude? If our p-value is less than alpha, we reject the null hypothesis. We have evidence for HA in context. If our p-value is greater than alpha, we fail to reject the null hypothesis and we have no evidence for HA. I am thinking that it's saying these are all spelled wrong because my daughter goes to RSI and her computer is in Spanish right now. I could be wrong, but I think that's why that's saying that. Okay, so let's go back now and let's look. We need to say, is our p-value less than alpha or is it greater than alpha? Well, we don't know what our p-value is, but we know that it's somewhere in the middle of these two values. Our alpha is 0.05, so we do know that our p-value is less than alpha of 0.05. Now, these two values right here won't always match up. It just happens to this time. So we do know that p-value is less than alpha. Okay, so now I'm going to conclude. I'm going to say, because our p-value is less than alpha, I reject the null hypothesis. I have evidence that the true mean is less than 64. That's as much context as I can give you because I don't know what the true mean is, but I do know that the alternative hypothesis, the HA, is less than 64. Okay, so that's what you're going to do today, and we are going to practice it once. So here's our problem, okay? A college professor suspects that students at his school are getting less than 8 hours of sleep a night on average. To test his belief, the professor asks a random sample of 28 students, "How much sleep did you get last night?" He found of the 28 students, the average amount of sleep they got was 6.68 with a standard deviation of 2.06. The graph of the data was symmetric with no outliers. This graph of the data symmetric with no outliers is very important. Okay, I'll talk about that in a second. Let's get going right away. Our state, we learned this with the last video. Mu, null, alternative, and alpha. Mu is the true mean amount of sleep the students got. Does it say last night? I should have put, but that's okay. Okay. Our null hypothesis is saying what is the parameter as a value? What's describing the population? Okay. Well, it doesn't say what's describing the population. So sometimes we go to the alternative and we say, what are we trying to find evidence for? Well, he's suspecting that kids are getting less than 8 hours of sleep. So we're trying to find evidence that it's less than 8 hours of sleep. So if that's our alternative, that means our null has to be mu is equal to 8 hours of sleep. So we also know that's what he's trying to figure out. Do they get less than 8 hours? Again, it does not state an alpha, so we just assume that it is 0.05. Okay, as I said yesterday, or in the last video, I said, you know, I'm not in the class walking around making sure everyone's at a good pace. So it's up to you. You're going to have to pause the video when needed to write things down. We're back to the plan. RIN, random independence normal. Okay, it does say that we have a random sample of 28 students. Okay. A professor, it's a college professor. We're going to assume that that college is quite large. So we're going to say 10 times 28. We're going to assume 280 is less than all students. Okay. Again, that comes from 10 times the sample size is less than the population size. And again, I speak more, or I guess I speak more in depth about it in previous videos. And then n is greater than or equal to 30. Okay. So 28 is not greater than or equal to 30. So what we have to do then, you guys, is we have to say that it's stated that the graph is symmetric with no outliers. We learned about that last week with the interval, that if that doesn't work, something called the central limit theorem, that 30 comes from that. And we don't learn about that as much in regular statistics. We do that in AP and then in college. But it's okay to proceed because the t-distribution is what we call robust. We can proceed if that doesn't work. As long as the graph of the distribution is symmetric, it can be somewhat skewed actually too, but it cannot have outliers. Okay, let's go to the do. X bar, that's what's describing our sample, excuse me. So we look up at the problem and we say, what is describing the sample of 28 students? And that's 6.68. So that's our statistic right there. So I have that X bar is 6.68. The mu is what we get from the null hypothesis. So that's 8. The standard deviation, like we learned yesterday, the symbol is this, okay? And that's our SX divided by the square root of n. Okay, so the SX that they give us is 2.06, and we need to just divide that by the square root of 28, and I got 0.39. Okay, so next, our t-score. So what we learned yesterday, that's Tom's. It's what we observe, X bar, minus the mean of the sampling distribution, which is our mu, divided by the standard deviation of the sampling distribution, which is our sigma. 4 degrees of freedom of n minus 1. Okay, so I did that right there. And I really love this process because it's just saying, hey, take step 1 minus step 2 divided by step 3. And I have that right here. Okay, negative 3.38 for degrees of freedom of 27. So now we need to go to the p-value. Okay, so we go back to the chart. We're at 27 degrees of freedom. And I already forgot, negative 3.38. So we take that absolute value, negative 3.38, at 27 degrees of freedom. So here's 27 for the degrees of freedom. I'm going to use this row, excuse me. Okay, and I'm going to see 3.38 is in between 3.057 and 3.421. So I scroll up, which means my p-value is in between 0.001 and 0.0025. I'll do it again just in case you were lost. Our degrees of freedom are 27. Okay, our t-score, the absolute value of it, would be 3.38. I scroll across and I want to find the space where it fits in between the values. So 3.38 is right in between 3.057 and 3.421. I scroll up and I get 0.001 and 0.0025. So our p-value is in between these two values. Okay, I didn't write it very nice, sorry. Okay, we do not need to multiply by 2 because it is not a not equal to. So this is our final p-value. Now we need to conclude, okay? Now, we don't know what our p-value is, but we know at most it cannot be any greater than 0.0025. And 0.0025 is less than alpha equals 0.05, okay? So since our p-value is less than 0.05, again, we don't know what it is, but we know at most it can't be any greater or equal to this value, okay? And this value is less than 0.05, okay? So as a conclusion, then our p-value has to be less than 0.05. So I stated it right here, okay? Because our p-value is less than alpha, we reject the null hypothesis, and we have evidence for the HA. What is the HA? The true mean amount of sleep the students got last night is less than 8 hours. There we go. All right, you guys, that's it. You guys made it. 1 year of stats down in the books. Congratulations. And I will send you like a little send-off video here next week sometime. You guys take care.